I'm going to talk about the dynamics chapter of coefficient of restitution. Coefficient of restitution. So generically, the idea, what is coefficient restitution, is that I would say is the ratio of after versus before speed. So for example, like if you have this is your ground and you drop a ball that falls down, it drops at speed v, velocity v, and it's gonna bounce up, but it doesn't bounce as equally the same height. So this is your after speed, and it loses speed over time, and eventually it will go lower and lower. It doesn't bounce as much anymore. So the point is that the formula for coefficient restitution is always the change of speed after over the change of speed before. So this change itself does not mean the change of speed, but the change of speed between the objects. And in this case, it is the ball and the ground. So these are your two objects, object 1 and object 2. So yeah, so basically if you have two type of collision, you have two types of collision, and you have two types of way it collides. So the first collision is you have inelastic one, which is you have two objects, it collides, and inelastic means it sticks together and it goes with the uniform speed. And the second one is that you have two objects, they collide, and then they go is at this individual speed. And the way we usually know this is that if we have the coefficient of friction in the formula is always like this, given that when it is 1, it is perfectly elastic, and at 0 it is inelastic. So this is inelastic and this is elastic. The thing is that it would never be ever perfectly inelastic, because when they collide, they always release a form of energy in terms of sound or heat. So yeah, so it would never actually really be 0 or 1. Even if you're in space and it's vacuum, there is still loss to sound, just that you can't hear it because there's no transmission of sound. So so let's say if you have an object that is traveling at its two individual speed, so call this object 1 and object 2. The formula for restitution is always equal to the speed of object 2, after collision speed of object 2 minus the after collision of object 1 over the initial velocity of object 1 minus the initial velocity of object 2. So always remember, don't try not to confuse yourself with this thing. So you know it's always opposite. Yeah. And to kind of set this aside, one of the things that you need to understand as well is that that you have another form of collision, is whether it's inelastic or elastic, is that we have one that is a head-on collision, and another one is that you have a oblique collision. Call this head-on. So this is your plane of collision, and this is also your plane of collision. And one of the things you need to understand is that when you have a ball that is falling vertically, you throw a ball vertically, the ground exerts an equal amount, exerts a reaction force of N. However, if you have a ball that you're throwing at an angle, all the way here, the N is also still vertical, and even though your ball is now transmitting, it bounces perpendicular to the ground. It bounces against the ground, and it bounces like this. So one needs to know that your velocity of coming you throw the ball at the velocity v, and let's call it v0. So your v0, you have two components. You have v0x and v0 y. Let's say I call it a vy0, and I'm gonna call this vx0. So now what happens is that your ball, once it bounces, it moves at two different velocities. It's gonna move at v1, but you have v1 y, vy1, and you have vx1. So because you only have a reaction force from the ground that is pointing upwards, this actually proves that your vx1 is always equal to your vx0. However, your vy1 is actually the coefficient of restitution times your vy0. So that is the thing. So you should always remember is that you never have a coefficient of restitution when it is parallel to the ground. So this is because it is parallel to the ground, and this is because it is perpendicular. So yes.